Sorry I can't be there today, but I've made you guys this video. I'm going to step through it. It's really, really important that you practice all the factoring. I know you learned it last year, but it's so important that for your next homework, next class, I'm going to be checking your homework and I'm going to be marking your homework quiz. All right, so lesson 2.1. We're going to go through all of these. If you're watching me on video, then you can speed me up. Factor the following. For this first one, there's just two terms. Neither of them, well, the first one's a perfect square, but the second isn't. So we're going to factor out a GCF. And that's going to be the first thing we do with all of these. So factor out a GCF. So I can factor out a 4x, and this time I'd be left with x minus 5 after we divide each one of those things. B is down below, so we have t squared minus 7t plus 12. This is going to be one of these ones where the sum is in the middle and the product is going to be your a and your c, or the last term if a is just 1. So in this case, our sum equals minus 7 and our product equals 1 times 12, which is just 12. So we need two numbers that when we multiply give us minus 7, and when we multiply give us 12, and when we add give us minus 7. So those two numbers are going to be minus 3 and minus 4. So I can write this directly as t, and I write my t's with the tail on it, or the bum, just so that it doesn't look like a plus. So t minus 3 and t minus 4. These numbers are directly the two magical numbers. For C has a value of a out front. So our sum right here, our sum, the things that it adds up to, is minus 17. Our product is going to be 3 times 10. Our product is 30. So two numbers that when we times them give us minus 17, but when we times them give us 30, and when we add them give us minus 17. The two numbers are minus 2 and minus 15. So we're going to write it down and then do decomposition. So we're going to decompose this middle minus 17k into minus 2k. That came from there. And minus 15k. That came from here. And then it's still plus 10. And then we're going to factor by grouping. And these are our two groups. So in the first group, I can factor out a k, and I'm left with 3k minus 2. In the second one, I'm going to factor out a minus 5 because I want to end up with still a 3k minus 2. So in order to be left with positive 3k, it means I have to factor out a minus 5. So I factor out minus 5, and I'm left with 3k minus 2. Now that's common to both, so it can be factored out. So 3k minus 2 and k minus 5. And C is now fully factored. D. This is a difference of squares. And just to remind you of that, if I've got a squared minus b squared, when I factor it, I'm going to have a plus b times a minus b. So in this question, I really am having b squared minus 7 squared. And when we factor that, that means I'm going to get b plus 7 and b minus 7, difference of squares. E, y squared plus 12y plus 36. I'm guessing it's a perfect square trinomial. Perfect square trinomial where it would be a squared plus 2ab plus b squared. So if we look at that, that would mean a equals y, b equals 6. And then we can check if this is true, because this should be 2 times y times 6, which is 12y. Yeah, so because it follows perfect square rule, the factoring rule normally would mean that when we factor it, it would just be a plus b all squared. The same is going to hold true if it was a minus sign there, then it would be a minus sign here. But anyway, this one's a plus. So that means for this one, when I factor it, I could go directly to y plus 6 all squared. And if you didn't see that, you could have done sum and product, where the sum was 12 and the product was 36. And the two numbers that add to give me 12 and times to give me 36 would be 6 and 6. So we could have written it as y plus 6 times y plus 6, which would have still led us to y plus 6 squared. F. Right away I see that they're all even, so I'm going to factor out a GCF. When we do that, we get 2x squared plus x minus 6. So I need a sum of a ghosty 1 here. So the sum is 1, and the product is minus 12. So two numbers that when I times them give me minus 12, and when I add them give me plus 1. Those two numbers are going to be 4 and 3. So the 2 stays out front. So 2x squared plus 4x minus 3x minus 3, because really we're just decomposing that plus 1x into the plus 4x and 3x. Factor by grouping. 2 stays out front. I get 2x, leave behind an x. Oh, I copied that wrong. 6 was here, so 6 needs to be there. So I get 2x, x plus 2, and I'm going to factor out a minus 3 because I know I want that x plus 2 again. That's how I recognized I'd made a mistake. And now that you've got x plus 2 in common, it can come out. So we get 2 out front, x plus 2 because that was in common, and then we're left, the remaining stuff was a 2x minus 3. So 2x minus 3, that's where that comes from. So F is now factored. Some more to factor. 3a, so the stuff is the GCF first, and the common thing to everything is just a 3. So if I factor out 3, what's left behind is a squared b cubed plus 9a, not 9, sorry, 3a plus 6b cubed. Maybe we could factor something out of just those. And what would we have left behind? We'd have an a squared plus 6. Yeah, no, and that's it. That's as much as we can factor. So sometimes it's going to be ugly. For b, x squared minus x minus 12. So in this case, our sum is that negative 1. Our product is negative 12. So our two numbers are minus 4 and 3. And because there was no a value in front of it, I can go directly to x minus 4. X plus 3, and that one's done. C, I can see right away that this is an a squared, and this is a 3 squared, and this is, sorry, not an a squared. That one's an x squared. And then this is 2 times x times 3 equals 6x, so it is a perfect square trinomial. And remember, those always end with a plus or minus b all squared. So in this case, it would be minus. So this one would just be x minus 3 all squared. D, GCF of 2. You don't have to write that. So that equals 2 times x squared plus 7x plus 6. Sometimes you can just see it right away. They need to add to 7 and times to 6. It's going to be 1 and 6. So it's x plus 1, x plus 6. And you need to practice enough so that you can just see those easy ones. This one, sum of, our sum is minus 1, and our product is minus 12. We had those numbers before, so it's minus 4 and 3. We're going to break down the minus x into minus 4x plus 3x minus 6. So I broke down the minus x into those. And a 2x out front, x minus 2 plus 3x minus 2. We take the thing that's common, factor it out, and then we see what's left behind, and we write down that it remains. F. I've got two terms. I see a 36 and 100. Those are both perfect squares. So this is going to be a difference of squares. So it would be the same as 6x squared minus 10y. 10y squared squared. And remember, normally it would be a plus b, a minus b. So when this factors, we're going to get 6x minus 10y squared and 6x plus, and then this one can be the minus. The order doesn't matter. The other way it would have worked. I'm just trying to keep it the same. But I should have noticed before that everything could have been divided by 4. So right now, I'm going to divide a 2, factor out a 2 out of here, and then a 2 out of there. So really it's a 2, 3x plus 5y squared, and then another 2, 3x minus 5y squared. And then I'm going to times those two 2's together, and I'll have 4, 3x plus 5y squared, 3x minus 5y squared. It would have been better if I'd noticed the GCF first, like I mentioned before, and then it would have been 4 bracket 9x squared minus 25y to the 4, but it would have led to the same place because that would have been 3x squared, and that would have been 5y squared squared. Okay, that was it for F. 4a. Factor the following. This is a perfect square trinomial. PST, because this would be 2x squared, that would be 5y squared, and this would be 2 times 2x times 5y, 20xy. So my answer is going to be an a minus b all squared. So when I factor this, my a was 2x, my b was 5y, so 2x minus 5y squared. And if you're ever not sure if you got the right answer, you can always distribute and make sure you did it right. This one, another difference of squares. So in this case, we have 7x all squared minus 4y all squared. So that's going to be 7x plus 4y, 7x minus 4y. Summary factoring methods. Step 1 is going to be that's a terrible L. Look for the GCF and factor it out, even though I broke that own rule. Step 2 is going to be look for the tricks. And by the tricks, I mean like difference of square or a perfect square trinomial. If there are 4 terms, difference of square has 2 terms that are subtracted from each other, right? 4 terms, we would do factor by grouping. If we have, I meant for that to be a different color. For 4, if we have 3 terms, if it's just x squared plus bx plus c, we would do the method that has, and also if we have ax squared plus bx plus c. For the first one, our sum would be b. Also for the second one, the sum would be b. For that first one, your product is going to be just C, but in the second one, your product is going to be A times C. And then we would do the whole thing where when you have your two numbers here, let's pretend our two numbers are like D and E. Then our answer would be X plus D, X plus E. But for this one, if our two numbers are F and G, then you're going to do that whole thing where you split B into F and G, and then you factor by grouping. Factor by grouping. More practice, leaving those for you. Also, when I come back, I want to show you guys crisscross factoring. Okay, factor the following. They're both even, so I'm factoring out a 2. 9x squared minus 25. I notice that I have a difference of squares, so it's going to be 3x plus 5, 3x minus 5. Done. I'm going to do C. So my sum equals minus 1. My product equals minus 30. So two numbers that are close together. 6 and 5. So my two numbers are minus 6 and plus 5. So I get 10x squared plus minus 6x plus 5x minus 3. Factor out a 2x. We're left with 5x minus 3. Because I want to factor out 5x minus 3 here, I still got to factor something out. So I'm going to factor out a plus 1. And that means when I write the stuff that's all factored, I'm going to have 5x minus 3, and what was left behind was a 2x with that plus 1, and that's really important. B. B is the sum and product. We need two numbers that times to minus 30 and add to minus 1. Oh, we just did that. So it is x minus 6 and x plus 5. This one is a perfect square trinomial. So 3x plus 5 squared. Because really it was 3x squared, and then we had a 5 squared, and it all worked out. For this one, 2x squared plus x plus 3, we need two numbers where our sum is 1 and our product is 6. And in this case, there are none. There are no two numbers that multiply to give you 6 but add to give you positive 1. So this is not factorable. F. This is the first time we've seen the 4. When you have 4, you're going to factor by grouping. So in the first two terms, I can factor out an n squared. I'm left with an n plus the minus 3. Then for the second two, I can factor out a plus 2, and then we'll have n minus 3. N minus 3 was in common, so we have n squared plus 2. G, factor by grouping again. So x squared, x plus 1. I know I want to have a x plus 1 in common, so this is another one of those cases where it's a plus 1. So the one that was in common was the x plus 1, and what's left behind is the x squared plus 1. X squared plus 1. H. Two different letters. But I notice that this is a perfect square trinomial, that this can actually be written as x minus 3 squared minus 4y squared. And now it's become a difference of square, where, just to make it obvious, a is going to be x minus 3, and b is going to be 2y. So when we write this out, a plus b, so x minus 3 plus 2y, and then x minus 3 minus 2y. I. For this one, we already have an x plus 1 common to everything. So we factor that out first, x plus 1, and what's left behind is 2x minus 3 minus 8x squared. I'm going to rewrite that second thing, and I'm going to factor out a minus 1. So I'm factoring out a minus 1. I just wrote it out front. So now it's positive 8x squared minus 2x plus 3. And if I sum product this, the sum equals minus 2, the product equals 24. Did I copy something down wrong? Because to add up to minus 2, but to multiply to a positive, I think that's it. That's it. So actually, this would have been okay to stop here. J. So for this one, because I hadn't looked at this ahead of time, I'm going to distribute it all and then see. So I'm backwards distributing. And now is there a different way to factor this? These both have m's. This b's both have ax's. Let's see if that works. So if I take out an ax, I'm left with a bx plus n. And if I factor out a minus m, I'm left with a positive bx, but it's plus 1. Okay, I'm going to think about that and maybe come back to it. Okay. I'm going to factor out an x squared, and then we're left with x squared plus 2x y squared minus 3y to the 4. So if I'm looking at this, I want a sum of 2 and a product of minus 3. So our two numbers would be minus 3 and plus 3 and minus 1. So x squared, break down that middle term into plus 3xy squared minus xy squared minus 3y to the 4th. Now factor by grouping, and we get x squared x, we're left x plus 3y squared minus x plus 3, xy squared, x plus 3y squared. So in common is this, so the x squared still out front, and then x plus 3y squared, and then what's left behind is, there isn't an x here. I was totally wrong. We took out a y squared and left behind the x. And we're left with x minus y squared, and we'd be done. So that came from there. And that came from there. Okay, I'm going to look at this a little bit more, but otherwise I think I'm done. A can come out of those. Maybe combine the ones with the B's. Let me try this. Let me try combining the B's. So if I factor out a B, I'd be left with ax squared minus mx. And then for the last two, there's nothing in common. So, you know what? I think this is already factored. I don't think there's anything, but I'll double check and get back to you. Okay, do your homework.